Okay, so this is the last video for chapter 3. I think I've overdone it a bit for chapter 3, so next time I'll probably keep it a little shorter. Excuse me if my voice sounds a little hoarse. I'm trying to power through this. But now we're going to focus on reliability, or 3 types of reliability, and how you can use scatterplots to evaluate reliability. Okay, so we're not going to be using scatterplots in the same way we've been using them with correlation. So it's going to look very familiar, but we're going to use it specifically, or use them specifically, to assess reliability. I have this image here just to remind you. Reliability is your ability to get the same measurement at every measurement of that variable, right? Here you have examples of reliability, well, examples I use to visualize reliability and validity, whereas on the left you have neither validity or reliability. In the middle one, you have reliability because you're getting the same measurement every time, but you don't have validity. Remember, validity has to do with accuracy, right? How accurate is that measurement? Are you actually measuring what you said you measured? But on the right, you have both. You have reliability, you're getting that same measurement over and over again, you're getting that bullseye, and you have reliability. Well, I already said that. And you have accuracy, right? So you have accuracy as well. So we have 3 types of reliability we're going to be focusing on. We have test, retest, INTERRATER, and internal reliability. And remember, reliability, think consistency, right? We're consistently getting the same measurement over and over again. So let me go ahead and move around a little bit. So when we're thinking about test, retest reliability, it's essentially what I've been discussing so far, right? Every time I administered this exam, this evaluation, every time I observed, I get the same reading every time, the same outcome, the same measurement, right? So for example, I have that example on the top right with which Disney character are you? You know, these became very popular and people have been doing them and trying to figure out what Disney character they are. And here you can see somebody who did it and got 2 different results, right? Because they got 2 different results, right, one after the other. This shows that this measurement is not reliable. It's not going to tell you you're Aladdin every time. It's not going to tell you you're Scar. It's just random, right? So it's not a very reliable measurement. Now, let's say you did the test on the bottom right, right? These were popular a while back, which these were like kind of like the top ones, but you had to do a survey. In this case, it says, which unpopular food matches your personality? Right? I took this, I got candy corn. Very suiting because I am very corny. I'm pausing for your laughter right now. And you should be done laughing right about now. So essentially, simply, we're just looking at, is that measurement giving you not reliable, but is it giving you the same measurement every time? Right, so I have an example there. So if you take an IQ quiz in January and then you take it in February, is it around the same range, right? If nothing else has changed, it should be. So can it just give you the same measurement every time? Test, retest reliability. INTERRATER reliability has to do specifically with observational studies. So when you're checking for INTERRATER reliability, so look at that word, INTERRATER. You're comparing 2 raters of behavior. So as you might guess, based on the fact that you're comparing ratings and, well, maybe it's not so easy to guess, but INTERRATER reliability is most relevant to observational measures. So I guess that's not too intuitive, right? But it has to do with observational studies specifically. We're looking at, well, how do 2 individual people, researchers, how do they assess the observational data they're looking at. That might be live and in vivo. They might actually be there observing people, or it might be their observation of videos. Either one is fine, right? Either one would fit under this, under observational measures. So you might have two researchers who go to a playground to observe children, right? And they're interested in looking at aggression. They're interested in seeing, well, is aggression gendered at a young age? So let's look at kindergartners and compare them to fifth graders, right? Now you go and you observe, and there's two of you, because you want to make sure you compare your observations afterwards and you have similar observations. And then one of you counts playful punching by boys, counts patting on the shoulder, and the other person doesn't count those. And then you get back together, you compare your notes, and you have different counts. Now, if you're the lead researcher, you're going to kind of be annoyed, right? Because you want to move towards good inter-rater reliability. You want to make sure that two researchers can observe the same situation and can come away from that situation with the same conclusion. If you have different counts, then that shows your measurement is not reliable. There's some issue with your measurement. Now, keep in mind that for your measurement to be valid, you need reliability, right? So if you can't establish that, you have issues. So in this situation I gave you, you might have issues because the operational definition wasn't well done, right? Maybe initially you decide, okay, any form of touching will count as aggression. That's our definition. That's how we've decided to count aggression. Now that has issues with, in terms of accuracy, but let's say that's how it was defined. You come back, you discuss, you find out, oh wait, no, but I wasn't counting playful punching. I wasn't counting pats on the shoulder. We should redefine our definition or our operational definition and go back and then compare afterwards. You do that, you come back, you have similar counts of aggression. Now you have better inter-rater reliability. Now, internal reliability is specifically focusing on surveys. Now, let me review something really quickly. In a survey, a set of questions measuring one thing. That might be mood, that might be access to education. If you have a series of questions measuring that same thing, that's a scale. So in internal reliability, we're looking at, are all these questions within a scale? Are they accurately measuring the same thing? Right? That's what we're asking. So take a look at that bottom scale. So we have 5 questions. In most ways, my life is close to my ideal. The condition of my life is excellent, or the conditions of my life are excellent. I am fond of polka dots. I am a good swimmer. If I could live my life over, I would change almost nothing. So what do you think this is measuring? Most students, accurately guess, well, it's measuring something like happiness or happiness with life, something like that, right? So, okay, good, yes. So that's what this is designed to measure. Given that, which of these questions do you think don't fit with that overall theme, or would not be good measurements of happiness with life? So most people pick out 3. I am fond of polka dots. That's right. That one would give you poor internal reliability. You want to make sure that all your questions are measuring happiness reliably, right? I am fond of polka dots wouldn't do that because, I don't know, you might be unhappy and like polka dots. If I was forced to throw out another one, it would be number 4. So number 4, I am a good swimmer. While it may relate to happiness, right? You could say people who swim more are happier. We're not trying to make any correlational claim. or association claim here, we're trying to see, well, are these questions measuring happiness directly? And are they doing a good job of it? Now, given that, I would throw that fourth one out as well. And what we have left would most likely give us a reliable, consistent measure of the same thing across questions, right? People who answer highly on number 1 would probably do the same thing in number 2 and number 5. They should indicate they're happy across questions. Them being a good swimmer wouldn't really inform our understanding of their happiness. Neither would polka dots, like whether they like polka dots. So we want to make sure that all the questions in the scale are measuring that one variable we want to measure accurately, well, not accurately in this case, consistently, that it's consistently measuring the same thing. So if they're high on happiness in one question, that should continue throughout. And actually, before I move on to the next slide, I do want to point out, make sure you remember that one statistical assessment to assess internal reliability is a Cronbach's alpha. You could see that right before the scale. So what I'm going to tell you about the Cronbach's alpha is that we can use that to assess internal reliability. It gives us a statistic similar to a correlation. It kind of tells us, once we have all our data, how closely tied were participants' responses, how correlated were participants' responses across the questions, right? So if it's measuring the same thing, there should be a high correlation across their responses, right? So you should have a strong Cronbach's alpha. So other than knowing that a Cronbach's alpha is used to assess internal reliability, I don't want you to know much more about that, or I do want you to, but you don't need to, right? For this chapter at least. Later on, we do get into what's a good or low Cronbach's alpha, but just remember that we would assess internal reliability using a Cronbach's alpha, and it's also good to know that in general, it's kind of doing a correlation between people's responses and making sure that they're consistently responding across questions. Just to kind of gain some insight, we actually calculate the Cronbach's alpha after we collect data. If you get a poor Cronbach's alpha, that means you have to go back and collect data again after making modifications. So if you recruited 100 participants or 200 participants to check your scale, yes, you might still have to go back and re-recruit 200 more if it didn't work out. So now we're going to go into how you can use scatterplots to evaluate reliability. Okay, so again, just remember, you've seen scatterplots before, but we're going to use them a little differently here. So here's a scatterplot where I'm looking at test-retest reliability. So it looks like a correlation. It essentially is a correlation, but we're looking at the correlation between measurement 1 and measurement 2, right? So we're looking at that measurement, a single measurement. In this case, they're measuring head circumference of participants, and each name on there, Taylor, Kendra, Mateo, Kurt, that's a participant. Under column 1 on the left, you have measurement 1. Then you have measurement 2 on the column on the right. So look at Taylor. The first time we took a measurement of its head circumference, we got 50. Then we got 52 on the second measurement. For Kendra, we got 61, then 59 on the second measurement. For Mateo, 65, and then 64. For Kurt, 75 and 80. And if you look at the scatter plot, you can see what this looks like. This looks good. So for any situations where you see them using a scatter plot to assess reliability, we always want a positive correlation. So that's one thing to keep in mind. we do want positive correlations when we're dealing with reliability. When we're looking at association claims with two different variables, it doesn't really matter. It could be positive or negative. But when we're dealing with reliability specifically, we always want to see positive. So when you look at this, you could see, well, yeah, it looks like a pretty strong relationship based on what I can see. If I gave you this scatter plot, be able to, just based on the scatter plot alone, tell me whether they're checking for test, retest reliability, inter-rater reliability, or internal reliability. So the way you would know that, look at the x and y axis on the scatter plot. It says first and second measurement. Okay, so now you know they're taking two measurements of the same thing. Right away, you should know that's test-retest reliability. Just because they're taking two measurements the same way. For inter-rater reliability, this has to do with, well, in the scatter plot, you can see that there's two different observers, right? So what you're looking for to see, well, is this inter-rater? Is this test-retest? Is this internal reliability? You're looking at the x and y axes. Here you can see you have observer Peter and observer Mark. Or if you had something like researcher 1, researcher 2, observer 1, observer 2, that's a key giveaway that you're dealing with inter-rater reliability. Because anytime you're dealing with two observers, you're dealing with inter-rater reliability. At least anytime you're looking at a scatter plot that's about reliability and you have two observers, that's a giveaway, internal reliability. If you look at the actual dots, the names there are actually the people that the observers rated, right? So on the left, you have a situation where you have what looks like good inter-rater reliability. I said good, didn't I? Bad. No, that is bad. You do not want that. On the left, you have what looks like bad inter-rater reliability. And on the right, you have what looks like really good inter-rater reliability. So in all these situations, again, you want that strong positive correlation, right? It should look almost like the one on the right, where it's almost a 45-degree angle line. When you plot all those lines, it should be very clear that they're forming that line. Okay, so just a quick, very quick review of correlation coefficients. I do review that elsewhere, right? If we have a strong correlation coefficient or a strong correlation, positive correlation, because that's what we want for reliability, you would have something like 0.8, 0.7, 0.93, and that should be positive. Now, I do want you to remember that when we're dealing with an association claim or a correlational claim and not dealing with reliability, we're comparing two different variables like caffeine and attention. In that case, a negative correlation coefficient is okay. But when we're dealing with reliability, we want it to be positive, like the image on the left you see. But outside of this, it could be positive or negative, and it's fine. It just depends, right? So just again, very superficial, very quick review. But when the dots are closer, and you could see the line forming, right? And it's going from the bottom left to the top right, or top left to the bottom right, right? So it's forming a strong 45-degree angle from the bottom left to the top right, or from the top to the bottom, then you have a stronger relationship, right? The closer the lines are together, the stronger the relationship. The further away and spread out the dots are, the weaker relationship. Also, if the lines are completely horizontal, you don't have a relationship, right? So keep that in mind, right? That the R coefficient or correlation coefficient tells us the direction and the strength of the correlation. Let me just go back. So positive goes from the bottom right to the top right. Strong, a 0.9 is strong, 0.8 is strong, and tells us that they should be clumped up together like that and almost forming a line. On the right, that negative tells us that it should be coming from the top left to the bottom right. And because it's about 0.6, it's still a strong relation for psychology, don't get me wrong, but it's not as strong as a 0.9. So you would expect them to be spread out a little bit, but you should still be able to see a line, or it's more like an oval, right? A stretched out oval. But you should be able to see a direction. If you can't, and it's just kind of like you threw a bunch of, I don't know, paint at the wall, like polka dots, and they hit the wall, and there's no discernible pattern, then it's most likely that you have either a very weak correlation or don't have one. So just to review and recap, if you're measuring a participant twice, that's test-retest reliability. If you have two different raters or observers, then you're checking for inter-rater reliability. If you're checking to see if different items on a scale align with each other, right, then you're checking for internal reliability. So that's kind of the shorthand version of these. Again, if you have any questions, please let me know.